Okay, so what is the relationship between the price of a bond and the interest rate? What is the relationship? Price of a bond and interest rates. Probably heard this in some other places. How are those two things related? Interest rates go up. Federal Reserve is talking about raising interest rates at the September meeting coming up. Interest rates rise. What happens to prices of bonds? They go up or down? Just kind of talking about the directional relationship. They go up. So interest rates up, price of bonds up. How many people have heard the inverse relationship between price of bonds and interest rates? So it's actually the opposite, but try not to even let that. If you can remember this formula, it really tells you, right? If the denominator goes up, the effective interest rate goes down. It's the whole expression. If the denominator gets bigger, then that means this one gets smaller. And vice versa, if we take the price of a bond, which we'll do this too, we can rewrite this equation like this. If you know the current interest rates and you know the coupon payment, you can estimate the value of it. As interest rates go up, prices of bonds go down. Same thing. The denominator is getting bigger, the overall expression is getting smaller. This equation, as interest rates go up, the present value of the asset goes down, right? So that's all connected. So that is by definition. You'll often hear people say, well, maybe in the news media, well, when interest rates rise, prices tend to fall. Well, they don't tend to fall. They actually fall. Unless there's ceteris paribus, they actually fall. Because the way we define the thing in the first place is this. So it has to happen, but if there's something else that happens in the economy, maybe prices went up, but that's because something else changed. So one of the most important things here is the inverse relation between the price of the bond and interest rate. They move in opposite directions. Increase in interest rates leads to a decrease in the price of bonds. That's the relationship, but it technically holds by definition. That's the thing I kind of want you to remember. For one thing, you can go back to any of these formulas and you'll get that inverse relationship will just pop out at you because it's always in the denominator is where the interest rate is. Okay, questions there at all? All right, let's take a look at the screen here. Maybe this button seems to be a little sticky. Come on. Well, maybe my finger's just fat. I'm not sure. All right. So, face value. What's that? From last time, face value. What's that? What you what? What you bought it for, not necessarily you, but somebody bought it for, right? The original issuer, so when it was a treasury bill, it was Obama. Obama needed to raise $10,000 to pay for weapons of mass destruction, didn't have the money and went and sold a $10,000 bond. So on that initial public offering of the bond, it said $10,000. So that's the face value of the bond. Who's ever holding that bond instrument at the end of the term is going to get paid $1,000, $10,000 from Obama, right? They turn in that piece of paper and they're going to get the face value. So that's ultimately the redemption value of it. So this little chart here looks at the yields to maturity on a 10% coupon rate bond maturing in 10 years. So what's going on here? Why would we think about the bond having different interest rates? Which is what our yield to maturity is. So we got the negative relationship. So I think Kimmy maybe brought up discount at one point, didn't you? But do you know what you meant by that, or were you drawn from another class? Do you know what you meant by that? I just remember you making the comment. I don't remember what it was.
Oh, I was like buy it at a discounted rate and then get some face value back.
Okay, good. Yeah, so where up here are you seeing bonds at a discount? On this chart. If we say the bond is sold at a discount,
Anything above 10.
Anything above 10
Right.
or below the face value, right? So the face value is kind of anchoring our spot. That's the redemption value of what Obama's going to pay at the end of the term. But it's possible that if you sell it today, somebody might be able to pick it up at a discount. What would cause that? What would cause somebody to pick this bond up for $800? It's a $1,000 bond. It's like, well, that's dumb. The market, how so? In today's market, right? Yeah, so that kind of comes back to that comparison we started doing before. If today's interest rate environment is a market rate of 13%, which Lord help us if we get up that high again, but for maybe a junk, this could be junk bonds here, not government bonds, although this one says, yeah, this one says generic, so good, we're in the junk bond world here. This is real world here. This is for junk bonds. This is probably right in the sweet spot today. I read an article in the Wall Street Journal last week and said the junk bond activity has jumped quite a bit in the last 1 year to 2 years. So junk bonds get their name because they have higher default risk, but they're not totally junk. You just don't throw them in the garbage can. There's people that want to take on that type of risk. And so with that risk, you get some higher returns potentially. So if today's market for junk bonds was 13.8, then the only way that this bond can be unloaded today, if the bond's out there in the market and Kurt has the bond, the only way he can dump that sucker is to price it at market rates, right? So we kind of go with the interest rate being 13%. In order for him to sell this thing on Wall Street to Matt's got opportunities. Matt can go to the market and get similar risk junk bonds for 13.8. So he has absolutely no incentive to buy this from Kurt unless it's priced accordingly. And in today's market environment, it has to be priced at a discount in order for that to be working. The yield to maturity comes back to us from this equation. It's essentially solving for I, the internal rate of return, like we were doing last time. Because now we've got an equation of I can buy Kurt's junk bond at $800. I know that the coupon payment, did they tell us the coupon payment on this? I don't think they did they? Yeah, they just said the coupon payment, though, is fixed, as we know. So the coupon payment divided by 1 plus I raised to the 1 power, dot, 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 out to the n power, to n being whatever. So the coupon, if it's got 3 years left or whatever, that equation is solvable for I. That's the internal rate of return that you might have saw in other classes, and I think it's referenced here. But in the bond world, we call that the yield to maturity. This particular instrument, if purchased from Kurt at a discount, is going to yield an internal rate of return of 13.81%. Okay? See some most head shaking, a couple blank stares. What about if it sells at a premium? 1,200. What does that say about market rates? Market rates are down. Down compared to what? I'm pushing it. I haven't heard this answer yet. Market rates are down compared to what?
The rate when you bought it.
When that bond was issued. Good. To get it right specifically to the date, it's when this bond was issued, because our benchmark is 10. So what that says is that when this junk bond was issued, junk bond market rates were 10% for this type of risk bond, right? And so now market rates have dropped, interest rates have dropped to 7%. So in order for Kurt to unload this sucker, in order for him to be willing to unload this thing, he's going to have to be paid more than the face value, because this sucker's paying out 10%, right? Essentially 10%. It's paying out more than what the market is. And so in order to get Kurt to sell it, somebody has to offer him more than the face value. It's going to sell at a premium. All right, so everything's kind of back to market rates driven, and that's what drives bond prices. So this is the bond market right here, where prices might fluctuate daily. They do fluctuate daily on bond prices. But implicitly, there's always an interest rate tied to the bond price. Those two things, you can think of one and the other. Price of bonds goes up, interest rate goes down. Interest rates go up, price of bond goes down. They have to by definition. Okay, questions on that? All right, so a couple other ones here. A discount bond. So a discount bond has no coupon payments. So what did it mean to sell a bond at a discount? Kimmy? All right, you set a discount and you get the face value back, right? So with a discount bond, there are no coupon payments, and so you're going to get the rate of return by buying it cheaper than the face value. It's kind of like a buy low, sell high type of thing, but it is a discount bond. So no coupon payment. No coupon payment. Buy at a discount, that's where the name comes from, and redeem at face value, which we've been calling F, right? Yeah, face value.
So you would receive $1,000 back.
Well, so you're going to buy it cheap. So the price of the bond, how do we calculate the rate of return on a discount bond? For a 1-year discount bond, let's say. How would you calculate the rate of return if this is what's going on? We're going to buy at a discount and redeem at the face value. For a 1-year discount bond, how would you calculate your rate of return?
Face value minus discount, discount.
The discount price, right? The price of the bond, yeah. So if we take the face value minus the price of the discount bond, let's call it PD, over the price of the discount bond. So for example, if the face value was 1,000 and the price of the bond today was 800, what's the interest rate going to be? 1 year out, 25. We got $200, right? So if we plug in the numbers here, 1,000 minus 800 divided by 800 equals 200 divided by 800 equals 25%. We're back to the old rate of return of new number minus the old number divided by the old number. That's all we're doing, right? Now, this should look suspiciously familiar. I'm going to link these two concepts for me and bridge the gap for me on something that we did earlier at the beginning of the hour today. This is kind of a special case in a sense. What was the first thing we talked about today? Go ahead and look back at your notes. First topic, console. Console interest rate was calculated as what divided by what? Coupon payment over the price. Now look at how similar this is, right? I mean, we basically said it in different words, but at the end of the day, there's no uncertainty. You are going to get the $200 coupon payment, but now it's paid in the form of this discount divided by the price of what you paid for it, right? So it's very similar in terms of what's going on with the calculation. Okay, so you're granted a big enchilada. We've been working our way up to this one now. So, example, rate of return. So rate of return for a bond held 1 year. This is a regular bond. So the rate of return, just using the textbook language here, the rate of return is equal to C over PT plus PT plus 1 minus PT over PT. Write that all down, and then I want you guys to tell me what the heck that means. So, number between 4 and 9. 1, 2, 3, 4, 5. Sheldon, what the heck does that sucker mean? Let's start with the first one. I'm gonna try to nurse you along here. What does C mean? Coupon. So that's part of the payment for bond, right? So this first part here, this is the rate of return. So we got the coupon, what's PT? Price of the bond in time period T, right? Like today maybe. So we've got the coupon divided by the price. If that thing was all by itself, what does that look like? What we did at the beginning of class. Good, you're following along. That's right. So that is the rate of return, kind of like the capitalization rate, kind of like the perpetuity. We've got a coupon payment divided by the price that we purchased something, right? All right, so that sucker. 1, 2, 3, 4, down.
You got the price plus 1 minus the price divided by the price.
Okay, talk to me in real words now. What's this? I mean, you did a good job of describing this. So what is PT plus 1 versus PT plus 2? Or T plus T, sorry.
It'd just be 1 over whatever the price is.
No. I'm trying to think of what is it? What does it mean? Like what's going on here? This PT plus 1 minus PT divided by PT. That should sound awfully familiar as something we did earlier in class. I'll give you, see, I'm not really trying to help you. I'm just kind of pointing in a general direction here. Right?
Yeah.
So now put it into words for a regular old bond. What does that mean? So what if this is a 10-year bond purchased in a 2009 vintage, purchased in 2016, right? This is similar to the example we went over last time. So the term was a 10-year term, but what if it went on right here? And then we've got a 1-year bond. This bond is held 1 year. So what is this capturing for us? Put some numbers for me. You can pick out any numbers you want. You can even use these numbers if you want. You know, what's this? Give me some numbers. How long is the bond being held? Well, I'm looking at the rate of return for a bond held 1 year. So we're only doing 1 year. So what did you buy the bond for today? You went on the market, what did you buy it for? 800. PT. 1 year from now, what do you think it's worth, or what do you hope it's worth? Your numbers, you're running the show here. 850. So if in PT plus 1 year from now, that bond is worth 850, what does this expression represent?
How much it grew?
How much what?
It grew. Got bigger.
It grew, how much it grew, how much it got bigger by, right? So it's the return on the bond in terms of the price. So what we have is two elements that make up the rate of return now. The price is kind of the asset price, buy low, sell high, which is what Dallas did with this one, right? So we get 50 over 800. That is a rate of return equal to what? 5/8.
0.04?
How much?
0.0625.
0.0625. So 625%, right? So we made 6.25%, but it gets better. Because what did Sheldon bring to the show here? Sheldon brought some extra return on top of that via the coupon payment, right? So if Obama or whoever it was promised to pay $80 on the coupon payment, then we might have something like 80 over 800 plus 850 over or minus 800 divided by 800. And we have 10% plus our 6.25%, giving us an average rate of return, or a rate of return on the bond instrument of 16.5%. Not too bad. Do bond prices always go up? No, we talked about selling them at a discount. So Kenny's got the discount thing going. If this was reversed, this rate of return would be negative, and it would be drawing down from the 10%. You'd add these two together, and this would be a fall. Is it possible for this effect to outweigh the coupon effect? You bet. So if the coupon payment, the easy one would be if the coupon payment's 0, this disappears. But if the coupon payment was relatively small, let's say 2% ended up being the coupon payment portion, then this was a negative 6%, then it could easily be upside down, and you lost money on it. Your rate of return was negative. Okay, questions on that? Now this gets a lot uglier. It gets a lot uglier if we're talking about T plus 5. How do we calculate that? Who wants to venture that one? T plus 5. We hold the bond for 5 years. Does the coupon payment stay fixed? Yes. In a bond instrument, the coupon payment's fixed, so that kind of helps out the math a little bit. So that part we could probably digest. So what if 5-year hold? So we want to figure out the return, the rate of return, which you're not going to be able to figure out real easily this way to get the simple sum like this is going on. It's the first part of that answer. Because we got some future value, present value stuff going on, right? So this won't work. So what if a 5-year-old need different formula? And the formula that you'd have to be looking at would be if you know some of that stuff, like what is the value of the bond today? So if in PT, if PT is known, you got PT as the present value today. Hey, I can buy this GM bond for $1,200 or $800, whatever it is, right? So I got PT, and then how would we handle the rest of it? 5 years, what about these coupon payments? What do we need to do? Coupon payments fixed by definition. $100 this year, $100 2 years from now, $100 3 years from now, $100 4 years from now, $100 5 years from now. What do we need to do? Chisholm? Bring them back in present value. Just bring them back in time. So we pull out our old bag of the tricks, and we're just 1 plus I raised to the 1 power, dot, 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 C5, C1, divided by 1 plus I to the 5th power. So that chunk handles the coupon rate of return. For how it relates to the price. And then what's the extra chunk we need to have? What else are we getting out of this? So all I did was say t plus 5 instead of t plus 1. Okay, so Paige is saying take in the p, t plus 1, t plus 2, t plus 3, t plus 4. So we need to do something in between? What do you think? You need to do a similar thing here? What's different between the pt plus 5 and these other things? Logan?
One, we need to here.
At the end, so what's the proper way to treat it?
Last.
The last one divided by what? Divided by?
PT's still around.
You get PTs down here, though. Let's think about what's going on. I'm selling it 5 years later. Whatever it is, it is. What do I need to do to treat it fairly in terms of present value? Chisholm. The only reason I'm picking on you is you gave the right answer before, and it's the same answer. Bring it back. Bring it back. This is money that you're getting 5 years from now. So bring it back. So what do we need to divide it by? 1 plus I to the 5th power. That's it. This stuff really isn't as hard. It looks complicated on paper. Like if you step back to your notes and look at what we did today, you're like, crap. Or show it to your friends. Say, this is what we did in money banking today. You show this to your friends, and they will crap themselves almost, right? So, but if you think about what we've done, if you're really listening carefully, we haven't done anything really different, right? We just kind of apply it in different ways. So this would handle the future price. And this is no different than what we did before. We take this rate, we solve for I. Remember, we can't solve for it algebraically, so this is an internal rate of return. It ends up being really the yield to maturity is what we're calculating on this bond, which is the same thing we started off with. But we didn't have this complexity of thinking about the price of the bond changing. So you've got two things just going on to remember: coupon payments and asset price change. Okay. Let's look at another overhead, I think, here. The other thing you might add on that some of you accounting, all of you, anybody not have accounting 1 and 2 with Professor Wagner? Not necessarily Professor Wagner, but anyone, everybody here has had 1 and 2, right? There's some of you that might be running it simultaneously. You're running, okay, you two are running it simultaneously? So this ends up being, for tax purposes, a capital gain. So I sell my muscle car for $30,000. I paid 20 divided by 20, give me my rate of return, but Uncle Sam wants a chip of that. So you held an asset over time and made money on it. This is kind of the capital gain portion of the return. And this one's really more like kind of the interest portion with the coupon payment, right? It's kind of the interest payments over time. Okay, so so this table is in your textbook too, and it shows the 1-year returns on different maturity, 10% coupon rate bonds, which is the normal bonds, when interest rates rise from 10 to 20%. There's kind of a lot going on with this thing. So market rates of interest have gone up from 10 to 20% since you bought the bond, okay? So there's been an interest rate in 1 year difference, interest rates rose, market rates rose. Okay, years to maturity. So if we're 1 year out or 30 years out, remember that's the whole purpose of this chart, is showing you different maturities. Initial current yield, they all initially started off at 10%. Initial price, all of them were $1,000. So then the price next year is where we get kind of weird on us here. What's going on there? The price next year. I think this will help to start here. Why is that one the same? Why is that one the same? So we got 1 year returns on different maturity, coupon bonds. Now the initial current yield was 10%, so what is the coupon payment? What's the C in this case, the coupon payment? 100, right? So it was a 10% bond, so the coupon rate was 10%, because that was the initial. This one's a good one to just kind of stew on for a sec here. Who's got it figured out? Yeah.
It's only held for 1 year.
Okay, it's only held for 1 year. So what is true about the price next year? Why do we say price next year 1,000, but it was just a 1 year bond? Kind of a unique anomaly here. What's that price next year effectively equal to, since it's just a 1 year bond? What's it equal to? We held it a year, it was a 1 year bond. At the end of the expiration, what does the bondholder get back? The face value. So they're getting the $1,000 back. So let's say that we're at 364 days and 23 hours and 30 minutes of the 1-year bond expiring. Okay, you with me on that? So we're like a half hour before the 1-year bond, and Kurt wants to sell it to Matt. Oh, what's it worth? With 30 minutes left, you want this sucker? It's basically worth $1,000, right? So if he sells it to him, it's worth $1,000, because just wait a half hour and you're going to be able to redeem it for $1,000. So this is the price situation. You basically held it to maturity, and so you didn't have any capital gain effect, and you got a 10% rate of return. You just held it for the 1 year. The government paid their coupon payment, and you're all done. So what's going on with this? Let's jump to 30 years. How do we calculate the price next year? What's driving that result? Capital gain is kind of big here, right? But this is big too, or the total return, yeah. So we've got the price next year. The capital gain rate is biggest. But what's driving this low number? What happened? Like I said, there's a lot going on with this one. Interest rates rose, and so what happened? Price went down. So if we do our whole 30-year calculation, what's the proper I to put into our formula? What's the proper I to plug in? The 20%. Right? So if we discount that 20, we're going to get a lower number for a lot of time periods. And so they give you this little note here that they used a financial calculator to calculate the internal rate of return. That means that the value of this future income stream is only worth $500 next year if interest rates went from 10 to 20%. Now, what about this one? What all do we have going for ourselves with the 917? The price of the bond, we're going to hold it 2 years, but the price of the bond today falls, I'm sorry, not today, the price next year falls to 917. What is the coupon payment that you're going to get from the bondholder? 100. And then what would be the appropriate thing to discount by? What's the appropriate I? 20, because interest rates went up, right? So if somebody could take out their calculator, Kaylee seems to be on the fire today, so 100 divided by 1.2 raised to the 1 power, what does that equal? 83.3.
Short rate of capital gain.
Yeah. And that equals here, but the $83 needs to be discounted off, right? So the discount rate ends up being that $83 lumped off of it. So that's what we're doing each time with these, is thinking about the capital effect plus the coupon effect, and we get our difference between the two. All right, and what's the difference here between this rate and this rate? How much units are different? 10. How about this one? 10. What's driving that? 10% coupon. All right, so we're right back to those two pieces of the puzzle. All right, we'll call it a day there.
Early, wow.
Yeah, mark your calendars. Did everybody get on the sign-in sheet? Make it all the way? Nope, we did not make it to the golf club. That'll be Wednesday. We will get to the golf club. What's that?
Oh, it's still out there. That flew over and hit me.
Come on, that's right. I got it, I think.
Off your leg.
Yep.